to note is if it said is a factor last unit, you always thought remainder 0, correct? That was last unit. You said is a factor, you thought remainder 0. We agree? When you hear on the unit circle, you think, hey, it can go into this formula. Because the formula of a circle, you take whatever the center is and you plug it in minus it here. So technically I would go, it's at 0, 0. So I would go x minus 0 squared plus y minus 0. That's where you put the center of the circle. And then you take the radius and you square it. 1 squared. Well, that's just x squared plus y squared equals 1. So this is the equation of the unit circle. So if it says on the unit circle, it fits into that equation. Remember I told you that yes, there's these lovely points at 45, reference angles of 45 and 60 and 30 and 90 that are on the outside of the unit circle that we have exact values for, correct? But that there are infinite number of actual coordinates on the outside of that unit circle, aren't there? Like there's a ton of degrees between 0 and 30 that would give me answers, wouldn't there? There's a ton between 30 and 45, and between 45 and 60, between 60 and 90. So there's way more coordinates on that unit circle than the ones we gave. Why? It's not staying on my ear. Move slowly. It's so bad today. It won't stay on. You said that last semester. Yep, didn't take it that helpful hint last semester either. No, I'm good. My hair. Okay. X squared plus y squared equals what? So let's flip over. These are your angles that you have. The center is a radius at 1. That's why we can use x squared equals y squared. And we have all of these between radians and degrees on our unit circle, correct? So here, they want us to state the coordinates of the intersection of the terminal arm and the unit circle. So here, this little p means the point at pi over 2. So I'm going to go to pi over 2, which is 90, and I'm going to write the point. What's the coordinate at pi over 2? 0 and 1, correct? So that's what I'm going to write. And then at negative 3 pi. So negative 3 pi isn't on our unit circle directly, is it? Like there's no like negative 3 pi written somewhere on our unit circle. There's actually no negatives written on our unit circle at all. But we can follow it around and find out where it would terminate, couldn't we? We could find a coterminal that would fall on that unit circle, couldn't we? So let's do that. So how would we do coterminals? We go negative 3 pi plus 2 pi, which would get us negative pi. Is negative pi on the unit circle? Nope. So I'm going to go again, negative pi plus 2 pi, and I get pi. So if I actually drew negative 3 pi, I would start here. I would go around 2 pi, and then I would go around another pi, and I'd stop here. So it actually would look like this, which is really weird. That's negative 3 pi. It terminates on the exact same spot, exact same point as pi, doesn't it? So actually, if I'm given any angle, and it's not directly on the unit circle, I can find its coterminal angle, find out if it terminates on the same spot, list that point. Okay? So I found that pi actually terminates on the same spot as negative 3 pi, and the coordinate there is negative 1 and 0. So that's what I'm going to write. Seven pi over 2. I want you to, is 7 pi over 2 on your unit circle? No, it's too big to be on your unit circle. So I'm going to find a coterminal with it. So I'm going to go 7 pi over 2. It's too big, so I'm actually going to subtract 2 pi as opposed to adding like I did before. So do 7 pi over 2 minus 2 pi. What would you get? You give me the answer. So if we do it actually math-wise, we'd go 7 pi over 2 minus 2 pi. You need a common denominator. This one's over 1. So I'd have to multiply it by 2 over 2. So I get 7 pi minus 4 pi over 2, which is 3 pi over 2. So this is the same terminating arm as 3 pi over 2. 3 pi over 2 is right here. What's the point at 3 pi over 2? 0 over negative 1 down. Because remember, those coordinates are just xy coordinates. And this radius has 1. 720, it's coterminal with, it's too big. I'm going to subtract 360. I'm going to get 360, which makes sense. It's just rotating twice. So it's on the same spot as here. What's the coordinate right here? 1 and 0. So we keep finding the principal angles. That's what we're doing here. We're finding the principal angle. It's the smallest positive angle between 0 and 360 or 0 and 2 pi. So we just find our coterminals because they terminate on the same arm and you can give me the answer, right? We just need to find an angle that's actually on the unit circle and list the points. So we can find the coterminals. So we find the principal angles. Try these ones. Give me answers. Okay, at 60, what do we get? 1/2 and root 3 over 2. 7 pi over 6 is negative root 3 over 2 and negative 1/2. Correct me if I'm wrong. I'm visualizing it in my head, which is making it a little bit, could possibly be wrong. 240 is negative 1/2 and negative root 3 over 2. 120 is negative 1/2 and root 3 over 2. Negative 5 over pi over 3 you could convert to degrees, or you could, which would be 300, negative 300, which would get you positive 60. Or you can go negative 5 pi over 3 plus 2 pi, which is over 1. I have to multiply by 3. So I'm going to get negative 5 pi plus 6 pi over 3, which is pi over 3. At pi over 3, I have 1/2 and root 3 over 2. 19 pi over 6, I could convert to degrees, subtract 360, or I could subtract 2 pi. So I'm going to get 19 pi minus 12 pi, which is 7 pi over 6, which is actually negative 210, or positive 210, which is the exact same as up here. And then this one's at negative 1, 0. It was above. We did it before. So you're literally finding the angle on the unit circle, the principal angle, and then we are just pulling the points off the outside, the coordinate of that angle. Okay? Okay. Here's some more. Give her. Pi over 2 is at 90, which is 0 and 1. 2 pi is over here, which is 1 and 0. 2 pi over 3 is at 120, which is negative 1/2 and root 3 over 2. 5 pi over 4 is in the third quadrant where they're both negative, root 2 over 2. Negative root 2 over 2. Negative pi over 4, calm, plus 2 pi. You're much too amped up right now. You need to calm down. So we're going to get negative pi over 4 plus 8 pi over 4, which is 7 pi over 4. The coordinate there is root 2 over 2 and negative root 2 over 2. 23 pi over 6 minus 2 pi. (23 pi), what's up? Yeah, over 6 minus 12 pi over 6 equals 11 pi over 6, which is 330. So it's going to be root 3 over 2. Shh. And negative a half. And we're going to flip over. You are going to need more than just that unit circle paper. I promise you, you are. Okay. Yep, the only person with the unit circle, and that's it. Okay, so now I'm giving you an answer, but I'm asking for theta. So what we did before is we went p of pi over 3, and you gave me the answer to pi over 3. We agree? Now I'm giving you the coordinate, and I'm asking for the angle. The catch is I could have so many angles, could I not? So if the answer was 30, I could then have 390. I could also have negative 330. I could have tons of coterminal angles that will land on that same point, correct? So we'd either have to give general solutions, or Zach, attack. Yeah. Still not going anywhere. It's a bit of an issue. Okay. This one is restricted between 0 and 2 pi. So if you give me the answer in degrees, what's going to happen? Nothing. Wrong. Okay. So you have to give me the answers in radians. This is the other thing too. Negative 1 over root 2. People get confused with that. If you're ever given that, that's just the unrationalized form of root 2 over 2. So in grade 11, we were taught this. You can rationalize your denominator by multiplying the top and the bottom by the monomial. So you get 1 root 2 over, what's root 2 times root 2? Root 4, which is 2. So whenever you multiply two radicals that are the same together, you just get the answer of what's under the radical. The reason why that is root 3 times root 3 is root 9, which is 3. Root x times root x is root x squared, which is just x. So when you multiply two radicals that are the same together, you get rid of the radical sign, because this would be root 4, so it'd be 2. So that's why you multiply by the same thing, to rationalize the denominator. So if you ever see 1 over root 2, that's just the same as writing this. They could have wrote this. Same answer. Okay, I want the answer on the unit circle between 0 and 2 pi. 0 and 2 pi is the unit circle. Okay, if I said between 2 pi and 4 pi, you take your answer from the unit circle and do what to it? Add 2 pi to it, because I'd want the next answer, the next coterminal. Okay, so go ahead and give me the angles, please. Okay, negative 1 and 0 is at the same spot as what? Pi. Thanks for answering. And then root 3 over 2 and a half is at the same spot as pi over 6. And then negative root 2 over 2 and root 2 over 2 is actually in quadrant 2. So some of you are like randomly looking, like, I don't know where to look. If it has a negative x and a positive y, it's in quadrant 2. Like, go there and look for it, right? It's good there. Okay? It's going to be 3 pi over 4. And then negative a half and negative 3 over 2 is in quadrant 3. And it's at the 60-degree reference angle. So it is 5 pi over 6. Nope. It is 7 pi over 6. No, it's over 3. 5 pi over 3. 4 pi over 3. Oh my gosh. Fourth time's the charm. 5 pi over 3 is in this quadrant over here. I had to think. It's a 60-degree reference angle, so it's over 3. Then I said 6, and then I just went out to lunch. So it was one more. 4 pi over 3. Here's another unit circle that you're going to get to fill in. You don't have to fill in right now, but you can do it for practice later, because it's so much fun. Over. Okay. Here it says, determine the missing y-coordinate for each point on the unit circle. So people freak out, and they're like, negative 4 over 5 is not on my unit circle. Therefore, it does not exist. Remember, there are tons more points on that unit circle. We just didn't make you have exact values for all of them and memorize them. That would be awful, right? So we just did the main ones, but there's tons of points in between. Remember I told you if it said on the unit circle, what do? X squared plus y squared equals 1. So we have an x, we have a y. Okay, let's try this out. So we're going to go negative 4 over 5 squared plus y squared equals 1. We're going to get 16 over 25. It's going to turn positive because when we square a negative, it becomes positive. Y squared equals 1. Then we're going to subtract the 16 over 25. So we're going to get y squared equals 1 minus 16 over 25. In order to subtract fractions, we need common denominators. So I can turn 25 or 1 into 25 over 25. So y squared equals 9 over 25. And then this is where people screw up. So review of factoring. This is what we're going to do. So for the factoring that we're going to review, it's either GCF, so that's greatest common factor. So that's like, hey, each term I can take something out of it. Every single one has an X, or every single one of them has a 2. And when you take out a greatest common factor, you're dividing. Okay? Or difference of squares. Difference of squares has the word difference in it. So if it's like x squared minus 9, we're going to remind us of this. It has to have 2 terms. It'll stop eventually. Sorry, it's the coffee maker. X squared minus 9. It has 2 factors. It's just talking. It's fine. It has to have 2 factors, and it has to have a different sign in between. So it's subtraction, because it's a difference of squares. The other thing is these need to be perfect squares. So what's the square root of x squared? X. And what's the square root of 9? 3. Because there's no decimals or anything crazy when you take the square root of them, they're perfect squares. So this is a difference, subtraction sign, of 2 squares. That's why it's called that. It's crazy. So we get 2 factors from it. Both factors are going to start with an x and end with a 3. And then one's going to have a plus sign in between and one's going to have a minus. It does not matter if you put the minus first and the plus second. You're multiplying, so it's not going to change anything. Okay? So whenever we go to do anything in the rational unit, we're going to, it's done now. It's going to stop. Whenever we're going to do anything in the rational unit, which is what we're in, we're always going to see if we can take out a greatest common factor or difference of squares, everything. Okay? So let's look at number 1. It says to factor. So the very first thing I'm going to always check for is greatest common factor. Is there anything I can take out of 25 and 45? A 5. Okay, so I can GCF a 5. And then I have a d to the 5 and d to the 4. And I'm going to show you something because this is why people get confused. So if I go 25, d to the 5 is d times d times d times d times d. Plus 45 d to the 4 is d times d times d times d. Yes, it's real. So how many d's can I take out? I can take out 4 d's. When I take out 4 d's, oh, it's not stopping. I don't know why. You're left with 1 d in the front because you actually subtract exponents, remember? So when you divide, you subtract exponents. So if you want to think about it that way, subtracting exponents you can, or you can think about it, hey, I have 4 d's, I have 5 d's, I can take out 4, I have 1 left. That is what I would do. But if you want to go the division route, you can. So I took a 5d to the 4 out. I have a bracket then. And then I say to myself, self, what do I have left here? So when I'm taking out GCFs, I'm dividing. So what's 25 divided by 5? 5. I have 5 d's, I take out 1. I take out 4. I'm left with 1. I gave the answer. Oops. Plus 45 divided by 5 is 9. I have 4 d's, I take out 4 d's. I'm done. I'm hoping it's done. Sorry. That's it. Boom. We're done. That's it. So let's look at B. B is a trinomial. It has 3 terms. The very first thing I'm always going to ask myself, though, is, can I take out a GCF? Before I do anything, that's what I'm going to do. And you should have done that in grade 11 as well. So 9k to the 4 plus 12k to the 3 minus 6k. What could I take out for a number? A 3. So I'm going to go equals 3, because what I'm saying is this equals the next statement, right? So I have to have an equal sign, not just floating statements floating on your page randomly. This actually equals the next one, so I have to put an equal sign. So I can take out a 3, and then I have a k to the 4, a k to the 3, and a k. So I have 4k's, 3k's, 1k. So I can take a 1 out of all of them. Some people say, well, I can take 4 out. We can't take 4 out of 1. That doesn't make any sense. So you always take out the smallest one, right? So I can take out a k. Then in the brackets, I write what's left over. So 9 divided by 3 is 3. I have 4 k's. I take out 1. K cubed. Then a plus sign because there's a plus sign. Then I say 12 divided by 3 is 4. K to the 3, take out a k. K to the 2. Minus sign. 6 divided by 3, 2. K out of k, none. None. you guys are going to do C to H. Try those out. So for C, what could I take out? A 2 and an x. If I take a 2x out of 8x squared, I'm left with 4x plus 10 divided by 2 is 5. X divided by x is technically 1. But 5 times 1 is 5, so it just goes away. But it's technically 1. So when you actually take the same exponent out of it, you're actually left with a 1. But when you multiply by 1, it doesn't matter. Bless you. And we need an equal sign. If you have no equal signs on your page, that is a problem. Insert equal sign. Okay. D, what can I do? Take out a 4. And 12 divided by 4 is 3y. Minus 16 divided by 4 is 4. Okay. E, what could I take out? Negative 15 or 15. Either one is actually correct. Which one's more correct? Well, we'll find out. I see a cell phone. Cell phones hurt me. They hurt me bad. It's like, they give me neck pain. Okay. I know, but it's real. Okay. So, negative 15, if you take out a negative 15 or positive 15, you wouldn't actually be incorrect. When we do rationals, we're going to have fractions. So we're going to have stuff on the top and stuff on the bottom that we're going to be canceling off. So what do we know what to take out? Well, whatever you take out that makes them both match with the correct sign is what you'd take out. So if taking a negative 15 out made the signs match, yay. If taking out a positive 15 made the sign match, yay. So you just take out what you need to. I'm going to take out a negative 15 just because it's all set. So negative 15, D3. If you took out a positive 15, you would not be incorrect. So negative 15 divided by negative 15 is actually 1, not 0. It's 1. If when you divided the same thing out, you got a 0, that term would be completely gone. Is it gone? No. So it's a 1. So we're left with D to the 2. 45 divided by negative 15 is negative 3. Do I have to go plus or minus? Could I do that? Yes. Will that be an answer? They would let it if it was a written response. If it's a multiple choice, when you do plus or minus, they'll just write it as a minus. So 45 divided by negative 15 is negative 3. D3 divided by D3 is 1. But I don't have to write it because 3 times 1 is 3. Okay, F was tricky. Nothing. Yeah. Mm-hmm. No, completely correct. 15 is that. G. I'm going to do G like this, and I'm going to do G like this. You answer, oops, this one. Answer the second one before I go through G. Do the second one. So the first one, what could I take out? A C. C cubed, take out a C is C squared, plus C squared, take out a C is negative C, take out a C is negative 1. Most people will do this one correctly. This one, however, same thing. If I take out a C, I'm left with C cubed, take out a C is C squared. C squared, take out a C is C. C, take out a C is, no, what did we say when we take the same thing out? Plus 1. So people drop that off. You can't drop it off. So when you're taking out a GCF, if you have 3 terms and you take out a GCF, you should still have 3 terms after you take out a GCF. If you have 2 terms and you take out a GCF, you should still have 2 left over. If you don't, you did the GCF wrong. H, I could take out a 6. And then I'd be left with n squared minus 5n plus 7, which actually can't factor because nothing multiplies to give me 7 and adds to give me negative 5. Okay, we're going to skip past these ones. We're going to go to K and L. Try them out. K, what could I do? take out a of, my fingers are held up to the number 2. 2. There's 2 fingers up, so 2. So we can take a 2 out, and then we're left with 9x squared minus 25y squared. High five to the person who noticed that that's a difference of squares. If you didn't, that's okay. We're just going through it. It's all right. Not taking away your high fives, just not giving you an extra one. All right. Okay. So the 2 is just gonna, it's just a bestie. It's just gonna follow its way down. Okay. So the 2 is great. Drop it down. This one, be suspicious. If there's an x squared or a y squared or something like that, there's 2 terms and there's a minus sign. Be suspicious that it's probably a difference of squares. Okay? Because this has an x squared and a y squared and a different sign in 2 terms, I'm like, could it be a difference of squares? You wouldn't notice the difference of squares until you took the GCF out, though. Because then you would have got decimals. Like if I would have went square root of 18x squared, it'd be decimal x. A decimal x. Is that good to make a difference of squares? No. But once I take the 2 out, I have the square root of 9x squared, which is 3x, and the square root of 25y squared, which is 5y. And so I put the 3x in the front of both brackets. I don't know why I didn't put 2. And then I put a 5y at the back. And then I put positive and negative in between. Then I'm done. You have to spot difference of squares. So often on quizzes and tests, when a student calls me over and they're like, I can't get this to reduce at all, it's because you forgot to check for difference of squares. That's about 99.9% of the time. So if when you call me over, I'm like, remember what I told you probably forget? Or I just look at you like, that's because you're forgetting the difference of squares. It's always that case. You'll even catch yourself and laugh when you call me over and I'm like, remember this point in life? Okay? If you don't remember it, I'm podcasting it. I can bring it back, you know? We can relive this moment for eternity. Okay, good times. What can we take out of L? 25 Z5. 100 and take out of 25 is 4. I have 9 Z's that take up 5, so I'm left with 4. 50 divided by 25 is 2. I have 6 Z's that take up 5. I'm left with Z. Minus 75 divided by 25 is 3, and I took out all Z's. We agree? Okay. Okay, factoring by difference of squares. I explained it to you already. These are your steps, but you don't really need them. We're going to see how you do. Go. No GCFs out. They're just difference of squares. Square root, bracket, bracket, plus minus. Try it out. So my b squared minus 64. Square root of b squared is b. Square root of 64 is 8. So I'm going to get an equal sign because this equals this. Equal signs. We need them. They're our friends. B plus 8, B minus 8. A squared, square root is A, 144, 12. And we need a different sign. What if we had an addition sign in between? What would happen? Could we do this? What's this called? A what of squares? A difference of squares. With a plus sign in between, would that be a difference? No, you actually can't. If it had a plus sign in between, you can't factor it. It would just be done, unless you could take out a GCF. That's it. So here we get A plus 12, A minus 12. This one, we would get 3A and 11. So we get 3A plus 11, 3A minus 11. Here we get X and 9. You have to put them in the order. So we have to go X plus 9, X minus 9. We can't do them backwards because if I FOIL this, like I'm expanding it out right now, right? If I FOIL it, I should get back to having the same question, shouldn't I? So this would be X squared minus 9X plus 9X, so minus 9X plus 9X. So that's the reason why we use opposite signs, because minus 9X plus 9X gets rid of the middle term. So that's why we don't have an X term. Nope. It just matters that you put x then 9. You can't go 9 then x. Okay. 324, square root of that is what? Help me. 18. 289, 17? 18a, sorry. So I'm going to get 18a minus 17, 18a plus 17. Okay, F. We could do this. In F, I'm just going to show you two cases. I could get 9 minus m, 9 plus m. But in rationals, often we'll have m minus 9, say in the denominator, right? Instead of 9 minus m, we'd have m minus 9. We agree? So that's the same terms, but wrong signs, correct? So then instead of going right into difference of squares, which this is completely correct. If you gave me that, I could not give you an error. Okay, that is completely correct. But what we could do is we could take a -1 out of this, and we could have wrote it as 9 or -9 plus m squared. Negative, what the heck? -81. Don't even know what I was writing. -81 plus m squared. But that looks really weird, doesn't it? That doesn't look like a difference of squares. So I would rearrange it. I'd go positive. You take the sign that's always in front of it. So I'd go m squared, then minus 81. And then I'd factor that. So I'm going to get -1, m plus 9, m minus 9. Then if I actually had an m minus 9 on the bottom, they would cancel. So which one's better than the other? Neither of them. It just matters when we do the rational question, which one is on the bottom or the top that we're trying to cancel. Okay? So right now, both of those answers are perfectly fine. One's quicker. This one, people do not spot as a difference of squares because they forget the 1 is a difference of squares. Because the square root of 1 is 1. I know you haven't done this one, but we're going to look at it, this one. This one I would star because people will spot every single one. It can be 289 and 324, and you'll square root those. But when it's a 1, you don't spot it because it's not like a screaming, hey, I'm a squared number. Okay? So once you spot it, this is the one where people will often leave the difference of squares just be this, and they're like, there's nothing I can do to it. But you actually can. The square root of 1 is 1. Okay? You're like, of course it is. And then you come to the test, and this will be the one you're going to leave. I'm telling you because I've taught this since 2012, at least 2 to 3 times a year. This one gets left all the time. Okay? So just trust me. Believe me. Maybe star it to remind yourself. Why am I starring this? Oh, right. The 1 is the square root. So 5x plus 1, 5x minus 1. Okay? So this is all review of stuff you've done in the past. Everything we've done so far, all review. Okay? Now we're starting rationals, which is somewhat review, somewhat not review. I may have to downsize the print on here. Huh, rational expressions, write that down. And what we're going to look at today are equivalent rationals and non-permissible values.